welcome everyone. So we're looking at data visualization and investigative journalism today. This is this is not a webinar format, so everyone, we can kind of see everyone. If you have questions, please post them in the chat on the Zoom as you go. If there are any issues, we do have a couple of people monitoring. If there are any issues, we'll try and address them as quickly as possible. But if you have any questions, post them in there, and we'll make sure that we've got some time to kind of address those towards the end, unless they're urgent, in which case we'll get to them as quickly as possible. Just quickly, so there's two of us speaking today, and that's myself, Alistair. I am the IT coordinator for the Global Investigative Journalism Network, as well as being what I would broadly classify myself as a data journalist. So a lot of work done around visualization with various sets of data. So I'm kind of bringing both of those two things together in this particular session. And with me is Jennifer Lafleur, Jennifer, do you want to introduce yourself just quickly?
Sure. I'm currently an editor at the Center for Public Integrity in Washington, D.C. We do investigations around inequality issues. And I've been a long time data reporter and data editor, investigative editor. And I love analyzing data, but I use visualizations to get to know my data. And that's the thing I will talk about.
Great.
Want to kick it off? Okay.
Yeah, thanks, Jennifer. If you want to start, so Jennifer will be running our presentation for us. I just want to make sure that I can see the chatting, just in case there are any questions, so I can see it. So Jennifer's going to be running the presentation. So if, every now and again I have a weird tick, it's because I'm asking her to move across to the next slide. It's not the internet. So in some ways, this is as Alistair and Jennifer Lafleur. This is what we're going to be covering. In some ways, this is a slightly different thing for me. My expertise is much more in data visualization, but having thought about this a lot over the last little while, it's become apparent to me that a lot of what we do is that we spend a lot of our time in the organizations that I work in, kind of digging through data, trying to make sense of the data. And oftentimes the endpoint is a visualization, but oftentimes the process to get to that is not, is a very a bit of a around the kind of process. Where we don't necessarily start out with an endpoint. So Jennifer, you want to jump forward and we'll get going. So really the premise of this, and we'll go through it in a couple of different ways. Really what we want to try and get across is data visualization is not necessarily just the endpoint. I mean, we see a lot of investigations and we see a lot of investigative journalism on the internet and in publications and elsewhere, and the visuals are often very impressive. But oftentimes, and in many cases, and what we're trying to get across here is that those visualizations are very much just an end part of the product, whereas you can actually use visualizations throughout the entire process. And at the bottom of the slide, I've got data visualization is a process, because I think what we have to understand is we're not only just trying to make a visualization. In some ways, we often use visualizations to make sense of the data that we have. And Jennifer will go through a lot of the more specific things and some ideas around how you can use specific types of data or find particular pieces. But I think it's important we kind of understand like why data visualization is a core component of any kind of investigation. And a lot of it has to do with the fact that oftentimes we have a lot of data. And we'll go through a couple of examples, but we have a lot of data in investigations oftentimes, and often that data is very difficult to imagine when you look at it in a spreadsheet or in a text file or whatever the case may be. It's very hard to understand exactly what's going on in that data. And this is where data visualization becomes an important part of that process. So there's a number of key things where data visualization is important in investigations. And that is, one is you can verify your data. And by that we mean, we'll talk about it to some degree, but what we mean is that when you see thousands of rows of data in a spreadsheet, you don't necessarily know if there's something particularly wrong. I mean, unless you're actively looking for something in that data, you don't necessarily know it. And then, whereas if you can turn it into a visualization, whether it's on a map or in a chart or whatever, suddenly something may jump out that makes it apparent that there's either a formatting area or there's an outlier, which Jennifer will talk about, but there's elements in that that are not normal or don't seem right. And oftentimes you can't see that just with rows of text or rows of numbers. So that's one way to kind of get a better sense of your data. There's also a very key component, and this is what we do a lot, is understanding the patterns in the data. When you're looking at a very large spreadsheet, it's very hard to understand if there's a particular pattern. I mean, if you know that if you're looking for a particular pattern, you can probably work it out. But if you're not really sure of the extent of your data, of what you've got, it's often very hard to understand that. And putting it into a chart or a map or whatever the case may be, oftentimes you'll see patterns which you may not have seen elsewhere, or you couldn't see just by looking at the data. It's also very key in guiding your reporting. If you're looking at a large set of data, certain elements will jump out when you actually turn it into some sort of visual, even a basic one. It may give you a better idea of where are the majority of these incidences located, where are the majority of these things focused, where are there certain people of a certain age, or are there people of a certain in a certain location. So I mean, it's sort of a tool in finding a way through the data and finding another way of looking at it and understanding it. It also makes sense of large amounts of data. And when you talk about large amounts of data, I'm not talking about like a few hundred rows. Sometimes those are understandable. It's when you've got tens of thousands of rows of data that may be, very difficult to kind of make sense of just by kind of filtering it in the spreadsheet. And I think the very important thing for us is testing your assumptions up very early on. I mean, it's kind of like make something, get an idea of what you want to, you imagine that your story is X. When you put it onto a map, actually there's a whole lot of outliers that suggest that maybe that's not the case. It's one way of kind of testing that and verifying it. So those are the kind of key core components of why we think that data visualization is important. If we want to go to the next one. And I'm talking very much from experience here, from personal experience here. But one of the things I think the biggest challenges with combining visualization and investigations and just data journalism in general is that it's very often people see kind of impressive visualizations and think, well, that's the end point, and that's where we're getting to. That's what we've got to do. And I think that there's a role for much more basic kind of formats and basic things. So the concepts and the designs that you may use in the process of investigating your stories don't have to be perfect. They can be rough. They really are kind of the first drafts, as I've got at the bottom there, of your working information. And we'll talk a little bit about what that actually means. But the big thing for me is that when you've got sets of data and you want to try and do something with it and try and understand it better, you need to create the space to learn to experiment. The ability to kind of play with different elements, look at your data in multiple different formats, whether it's in a bar chart or on a map, or there's a line chart and a scatter plot, and we'll talk about a lot of those going ahead. But it's important that we kind of experiment with the data and get as many kind of visions or views of that data as possible, as early on as possible. And ultimately, when you're doing visualization, oftentimes an investigation will result in a visualization of some sort. It helps to experiment early on with the kind of the charts and the pieces that the core parts of that are really the building blocks of visualization, and get a sense of what does this data look like. This helps not only in just kind of understanding your data, but also making you better prepared when you actually when you're producing your final product. You have a better sense of this may work rather than that. A bar chart may look a lot better than a line chart, or the outliers in this particular story, which we'll talk about, are much clearer if we visualize it in this way. And I mean, I think what's very important here, and we don't have it, I wouldn't thought about putting something in here, but not all data visualization forms are equal. So it's very much about playing with different things. A bar chart looks very different to a line chart, etc. But I think the technique that for us has been the most valuable, personally has been the most valuable, is finding a way to experiment. And I think that leads on to our next slide. So we teach a lot of data visualization and data journalism, and a lot of the thing that I find that people most often are hooked up on is that idea that everything has to be perfect. And actually the secret I found over a period of a long period of time is, one of the secrets to kind of getting through stuff is to actually find a way to experiment as quickly as possible. And by that, I mean, find something that you can play, some tool or some way that you can represent your data visually as quickly as possible with as little overhead as possible, so that you don't expend all your time kind of on the technology and learning a new tool, whereas you can just, rather than just kind of producing that data as quickly as possible so that you can get a good sense of it. And this very much is the draft that you're looking at. And we'll talk a little bit later about some of the tools that we prefer or we tend to use. But I think things like, there's things like Google Sheets, which I think are, which is an excellent way to start. Google's built-in charting tools make it very, very easy for almost anyone to take a data set and very quickly visualize it in some or other format. It's just a good starting point. Excel is similar, obviously. And then we can move to more advanced things like Data Wrapper and Map Shaper and things, and we'll give you a couple of examples of those. But the key for me to these is, one, they need to be easy to use. You don't want to take on board something that's very, very complex, that takes you spend all your time actually working on how to make a visual out of it. So try and find something that's very easy to use, so that the barrier to entry is as low as possible, and also make it as flexible as possible. A lot of the tools that we'll talk about towards the end are tools that are kind of allow you to take a set of data and look at it this way, and if that doesn't work, change it to look at it a different way, change it to look at it a different way. So there's multiple different ways of looking at it. And then I think I've probably said this before, try and kind of, the objective here is to try different ways of looking at your data and getting a better sense of it. And that could be based on, there's dimensions to your data, like data has, there's a component around size, or particularly geographic stuff around location, or where are things clustered, where are things grouped, and how do you quickly get to that so you can understand where those groupings happen, or where these incidents are located. And a lot of that does go back to mapping, but it could be for anything. Okay, so move on. And obviously, I think the thing that's really important here is data visualization for investigations particularly is most useful when there's very large amounts of data where it's quite hard to understand what it is that you have in your data set, or any data which is hard to visualize in a spreadsheet. And in many cases, the visualization, the data that's in a spreadsheet, say, for example, the obvious one is data that's in a spreadsheet which has got a geographic component, is often very, very hard to understand, particularly, or to imagine what it looks like, the shape of it, particularly if that data we're talking about is a geographic coordinates, like a latitude and a longitude. Most of us are not that versed in latitude and longitude that we can imagine where a latitude and a longitude point on the map is. Unless you are very conscious, unless you know very specifically what you're looking for. Oftentimes data like that almost requires being visualized in order for you to make understand of it and just to make sense of it. But I think that the thing is here is that it's large amounts of data that's hard to visualize, but in fact almost any data, whether it's large or small, there are ways of kind of getting a better understanding of that data by turning it into some kind of visualization. Should we move on? Yeah. So I'm going to start with something very simple. And these are, to give it context, South Africa, which I'm based in South Africa. South Africa had elections this last week. We voted on Monday this week. So we're in the midst of the last elements. I think one of the things for us, and this is something we're still kind of working on, there's elements to it. We've seen major shifts, and this is a very simplistic example, but I wanted to start with it. We've seen major shifts in the politics in the country. And essentially, like some of the key components that we started by taking a lot of the election results that existed Obviously we've got tens of thousands of voting stations and such like. It becomes very hard to understand all of that. The moment we put it on a map, on this visualization on the left here, this is a bit more of a final output, but we did an earlier one of this. Those red arrows going downwards are the voter turnout. And that's pretty much consistent. That's one of the provinces in South Africa. That's pretty much consistent across the entire country. We've seen significant drops in voter turnout. And those things we know in abstract were happening, but being able to kind of put them on a map makes it much more apparent. We started in this particular case, and I don't have the original, but what we did is we started with the data. I think in this particular instance, we used data wrapper just to kind of plot whether voting patterns had gone up or gone down. And then what became apparent and what became like our eventual visualization is clearly like the majority of the country changed its voting patterns, or the voting patterns changed. So we turned that into a visualization. So there was a process behind that. And the one on the right-hand side, the darker green, that's another province. That's the most populous and the wealthiest province, the kind of economic hub of the country in South Africa. All those greens are what we call hung councils, i.e. there was no definitive winner. Pretty much, and that reflects across the entire country. So these are very, very basic examples, but we did start with these at a very basic level. We visualized it on a very basic map. If you want to move on to the next one, but then prior to the elections, and these again are, unfortunately, they are the final outputs, but I wanted to give a sense, like the ways of looking at data. We had 93,000 candidates registered for the elections in South Africa. And there were a number of dimensions in that we kind of wanted to look at. And we did these, some of these we did in what's called R, which is a little bit more advanced programming, but some of them we also did in Flourish, which is a relatively easy tool to use. And essentially what we wanted to see is just, what is the age distribution of the candidates in the country? And that's the one on the left-hand side. That makes it, we can relatively easily understand, and Jennifer will talk very much more specifically about this kind of investigation, this kind of tool. But essentially what we're saying is that 70% of the candidates are under 50. What's intriguing is, and it's not the best visualization on the screen here, but that top line goes up to 90. We had people that were 96 years old standing for election, which raises a whole lot of interesting questions as well as the majority being young. The one on the right-hand side, candidates standing in 20 or more wards, which is intriguing. There were 166 candidates standing in 20 or more wards, and 8 candidates we discovered by actually plotting the 93,000 rows of data into a simple bar chart, is that there were 8 candidates that were technically running in more than 100 different wards. Those are voting areas, which raised a whole range of questions around not only the eligibility of these people to run in these kinds of, and it led to a whole story, but the eligibility, and also the fact that, one candidate representing 100 separate wards seems ludicrous. But these are the kinds of patterns that in 93,000 rows don't necessarily make sense. But if you plot them, and these are a little bit more final versions, but we started with very, very basic kind of inputs as well. So, okay, Janet, if you want to move on, Jen, thanks.
Those are amazing.
No, it's it's intriguing. So one of the things that we do, so this is a very, very basic kind of like approach to things, but a lot of the work that we do is around schools in South Africa. And so this is just a typical scenario. On the left, we have 25,000 schools listed in a spreadsheet with a latitude and a longitude. We have a particular problem in South Africa, and I haven't illustrated it here particularly, but we have schools with very, very poor infrastructure. And when I say poor infrastructure, I mean schools that don't have toilets and running water, for example. And this is not well illustrated here, but one of the techniques that we use the most often is we take this data, which is 25,000 rows, and which is very hard to because most of those schools are located geographically with a latitude and longitude, I use something, and this is going to come up a lot. I use something called MapShape. And MapShape is a fantastic tool for very quickly taking a set of data in a spreadsheet that has geographic coordinates and turning that into a map. So the two illustrations on the right-hand side, and they are just illustrative in this particular case, but literally that's a spreadsheet. I use an online tool called convert.csv, which turns it into what's called a JSON file. And these are slightly more technical, but you can read up about them. And then we put them into MapShape, and suddenly you've got a visualization of the country. You've got like a visualization of where these particular items are in the country, or these places. So, and I raise this, and this may not be the best example, but this is probably the technique I use as my starting point for almost anything that I do with any kind of data that's got a geographic component. Is I immediately try and find the quickest way to put it onto a map. And to me, MapShape is the best, but there are other tools out there. So that's just kind of what we did. We do a lot of stuff around school toilets, schools that don't have toilets, and this is the starting point for any of those. Okay, Jennifer. And this is another example. Same process. We started with the same process. We have schools in South Africa that are built fully out of asbestos, which is highly toxic and dangerous. We did an investigation over over a very long period of time. I can't remember the time period. I think it was a year or a year and a half, because there was no clarity on which schools in South Africa were built out of asbestos. And essentially we just started collecting documentation and slowly starting to map it down to the point where I think at the end was 29 schools in South Africa that we managed out of the 25,000 that are completely built out of asbestos, which is not only dangerous, but also illegal in South Africa, and essentially need to be replaced. So, and these are difficult to illustrate, but they just started with that big map of all the schools and then narrowed it down by attaching data to it, down to a point where we could actually say we have X number of schools in the country. So there's always a process in there, and that we couldn't really do that necessarily just by looking at a spreadsheet. Yeah, move on, let's go. And then this is something that we're still working on, and this is a whole different aspect. And this is a work in progress. So this is far from complete. In July in South Africa, we had protests which shut down large parts of the country. People buildings were burned, shops were looted, entire shopping malls were decimated, etc. And we've been collecting this data over a period of time, including social media posts, videos, radio reports. We've been doing this for months now. And in this particular instance, the problem that we had is we had like thousands of numbers, like hundreds of reports and multiple videos and that kind of thing. And the big challenge was, how do we actually turn this into something that we can make sense of? And in this particular case, we started with a timeline. As you can see, a lot of this is video footage that we've got, or Twitter posts, etc., which we try and kind of map out of a period of time. And this is very much a work in progress. We are still kind of working on this project. I'm hoping to finish it before the end of the year. But the only way we could do this is to do this in something like, in this particular case, we used a Figma, which is something similar to Illustrator, that kind of thing, which has the ability to kind of just jointly, and I mean, in this particular instance, we've got like 4 or 5 people working on it concurrently, just trying to map those things across. So I'm going to let Jennifer speak in a moment, but I think the big thing for us is like, how do we take stuff, how do we take large amounts of information or even information that's not particularly well structured and turn it into something that makes sense relatively quickly, so that we can build off of that into something more formal. Our final product is not going to look anything like this timeline. This is a work in progress, and this is just more illustrative of where we're going. So really, it's about how do we take that stuff, how do we turn it into something visual that we can understand, and then turn it into a final product. I'm going to let Jennifer pick up, and then maybe I'll come back and just cover a couple of tools and stuff towards the end.
Yep, absolutely. Such great examples. Thank you. So for me, I'm going to kind of go back to a little bit of basics on data and just how I use visualizations to better understand data. This is a major bridge collapse that happened in the US several years ago. And when something like this happens, we often get a report about the inspections of the bridge, and we all automatically want to know what's going on with the bridges in our community. I'm giving you an example from data here, but I've worked with bridge inspection data all over the world. So I know it's available in some places. It may be that it's on paper and has to be put into a database, but it's often helpful to look at. We all want to look at the database and see what's the condition of all the other bridges or the bridges in my community. And charting it out will give us some trends where we can compare places or we can compare data over time. But, mapping is, again, one of the most powerful ways to see this. This is from VG in Norway, where they mapped out all their critical and serious bridges. Seems like they have quite a lot of them. But this really gives you a sense of where there's clustering, where there may be problems, where to go do, on the ground reporting. This is a published map, but these types of maps are often very helpful, to use in the newsroom to help people decide where they should focus their reporting. Fires are another thing that I've had to do a lot of visualization on. I worked in California for a long time. I'm from Colorado in the Mountain West. So wildfires have been a part of my life for a while. And so one project that was done by USA Today and a newspaper in Arizona was to plot out all of the communities that have had significant fires, but also the escape routes. So they were able to kind of identify the places where they then should go on the ground and do more reporting. A similar project in Spain, again, showing kind of where the clustering was and where they might be able to go do more reporting. This was a published map for readers, but oftentimes these are also useful tools in the newsroom. So for understanding your data, before you dig in too much, you want to make sure that you've accounted for inconsistencies, missing data that seems out of range. So things where if you have, ages in the data and you have people who are 120 years old or people who are too young to be in the data. We were dealing with some voter data recently that would have meant that a significant number of voters were too young to vote. And so that's when you have to either go back to the source of the data or figure out how to account for it. Margins of error, and then just understanding the shape of your data. So for me, I love histograms. That might even be my band name if I ever have one. But what that does is immediately tell me a lot about my data. So on the bottom left, and this is the percent of people that have access to a doctor, it's a flatter distribution, it's more spread out. So that tells me that there's less extremes in this data. There are a few at the end, but compared to the top right corner where we have, it's income. So that is one where we see a lot of extremes. There's a long tail out to the right with people with very high incomes, and everyone else is kind of clustered lower. This third chart is a pretty normal, what we call normal distribution, which if you're doing any kind of statistical analysis, one of your goals is to have data that is normally distributed. It's pretty normally shaped. There's a few more calculations we might want to do, but this is just a first thing I always do at my data to see, okay, what do we have here? How is it distributed? What can I do with it? The other graphing tool that helps me a lot is the scatter plot, because that helps me look at the relationship between multiple variables. So the histogram shows me kind of how one value is going, one variable. But if I want to look at two different things together, a scatter plot will show me are these things really kind of going up at the same pace. So this top one is access to a doctor and mental health issues. Pretty strong relationship there. Again, I would run some stats to know what that relationship is in a number, but I always do a scatter plot first just to see. This is whether people get regular sleep, and whether this is the percent of people that say they get regular sleep and the percent of people that have had a stroke. Also a pattern, but a lot more noise, what we say noise and variation. So it's not as tightly related to the other variable. Scatter plots are also very helpful to just find outliers. Outliers might be problems in your data that you need to go back to the source and find more information out about. They also might be interesting stories. They might be a tip for stories. So this one on the bottom left is a one we recently used to look at foreign-born workers and wage theft, which is when companies aren't properly paying people, and there's actually a complaint filed and a case against the company for stealing wages from the workers. We were focusing on the garment manufacturing, which is way up here. But we had some outliers too that we later examined too, just to make sure that the data was really tracking what we thought it was. So visually, that's an easy way to kind of find those. This is a much older example, but I love it because this is where an outlier led to stories about schools cheating on test scores. Because the schools this is comparing schools 1 year to the next year. So reading in 4th grade versus reading in 5th grade. And there's really no way that a school could make this kind of jump. And so this helped the reporters identify the schools that might have had cheating to go back and do further reporting. I also use stock charts, and I never, ever do them for stocks because I don't map stock data, but I use them a lot when I have data that is from a survey or a sample. So this is median income for counties in the US. The red square is the estimate, but our statistics office, some of this data is from a sample, and so it also provides us with the margin of error. So we have the high, the low, and what they think it really should be. But I often use this to argue against running ranking charts, because as you can see, many of these could be sorted a different way depending on where they fell within the margin of error. So this is helpful to me to kind of see, like, do we have things that are really always going to be at the top? So if, for example, I sorted it, by the high number or the low number, the order of the counties would be very different. So for me, it's a very useful tool to just kind of understand my data and also to present my data to my colleagues. Mapping, and this is kind of clunky because this is one I used for reporting, not one that we published. We were looking at the areas around oil refineries. And so we looked at 5 mile, 3 mile, and 1 mile radii around oil refineries. And we wanted to look at the demographics. So we wanted to see, who was living near these oil refineries, often minorities, often people who are lower income. And we also wanted to look at health data. So one version of this is the percent of people that have chronic lung disease. And the other one is the percent of people living below poverty. So you can see that there tend to be more clusters of those populations near the refinery. And then we use these maps to identify the places where we wanted to go out and do further reporting. So we did a series of stories about life in the toxic zones and about those areas. But the maps are what we started with to identify where we should do reporting. This is an older example, but when I covered Hurricane Katrina oh so long ago, the first step we did was to do a map. We overlaid damage against flooding damage against where the federal government said places would flood against statistical data. And that gave us a map of where people lived that were had flood damage, but were told they didn't need insurance. And we were able to use the map to then go out and interview people along that way. This is a recent, and this is the published version, obviously, of a ProPublica project looking at, and this is something they had worked on for very long because the data is very complicated, but they were able to look at, and I'm totally oversimplifying, at the air pollution and how, you know, most of the air pollution in the US is measured at the source, but they measured air pollution at where they're all combined in neighborhoods, and we're able to show hotspots and clusters of where people are living with really high levels of cancer-causing pollution. I should say that we will give you the link to this presentation, and the stories are linked in the presentation, so you will have access to those later. So for me, I'm going to give a hat tip to our beloved former GIJNer, David Donald. Know thy data. Know your data really well. And doing some of these graphic tests of your data helps you understand it better. Check thy data. Make sure it's right. Make sure you've accounted for all the possible problems in it. And then, as Alistair mentioned, try different approaches. Look at your data different ways. You know, turn it over upside down to really make sure you're looking at it in all possible ways. And if you're looking at something more complex or data that's more complex that you're not totally sure about, talk to experts. Talk to people who work with this data all the time or similar data all the time and get their best advice. And just some couple examples of a little bit of caution. This was a story from a couple of years ago where a group mapped where people were watching pornography, and they created this hotspot in the middle of Kansas where everybody was allegedly watching more pornography online. What happened is, in mapping software, if some mapping programs, if they don't have the location, they map it to the center of whatever place you're looking at. And so in this case, Wichita, Kansas is the geographic center of the US. So it mapped all these addresses to the middle of Kansas just because it didn't have the information. So that's one reason you really need to know your data. The correction says it's like this vagaries of IP-based geolocation. Actually, they just didn't know their data before they mapped it. And just sometimes for me, I can just break things down to simple things. So this tweet said that, you know, Bloomberg, when Bloomberg was running for mayor of New York City, he spent $500 million on ads. The US population is 327 million. And they then followed with, he could have given each American 1 million, which is not the case. So sometimes if you just break it into tiny numbers, so if I had $500 among 327 people, it wouldn't be $1 million. It's like $1.54 or something. So just be cautious of that. This was a correction that I just thought was a little funny. there was an attempt at being very clever to nod at the history of a Broadway play that contains the words 525,600 minutes, and they multiplied that by 25 years, but they forgot to consider leap years. So the number was actually off because of leap years. Things that appear to be correlated might not actually make sense to be correlated. This is a website where this guy does all kinds of different spurious correlations. So it needs to not only be correlated, have a relationship, but it also needs to make sense. This is a cautionary tale from the UK where based on file format. So the old version of Excel only held about 65,000 rows. And so because of that, COVID cases in the UK were not being accounted for because there were records beyond the 65,000 rows that this old version of Excel they had could hold. So always make sure that the number of records that you have makes sense. We got some data the other day that had 80,000 people voting in a state that should have a lot more people voting. And so we had to go back because they, inadvertently filtered the data, and we wanted the whole data set. So we had to go back and ask for more. I'll tip it over to you, Alistair.
Okay, thank you. Yeah, Jennifer, there were a couple of very interesting things in that. Maybe I see there's a couple of questions, and some of which we may touch on some of the things that you covered, but we'll do that in a minute. So I think that the thing with the visualization is oftentimes it's a challenge to find like the right tools to do stuff and things that are relatively that are easy to use. So we've got a couple of things here, and there's a lot more than this. This is a very, very simplified list. But our point here is you don't have to be a coder necessarily to use data visualization tools. And the ones that from personal experience that we use the most often are Data Wrapper, which I think most people have heard about. Makes it increasingly good over the years. It's become very, very useful and widely used by a lot of news organizations. But Data Wrapper produces excellent final products. It's also really, really easy to use as a base as a starting point for something. So we use Data Wrapper a lot, as well as Flourish.studio. Flourish, if anyone's used it, is a fantastic tool for just taking some spreadsheet data, copying and pasting it in, and then particularly I like with Flourish Studio is it makes it relatively easy to kind of switch between different chart types. So you could have, you could have grouped bar charts or bar charts on their own or line charts or whatever the case may be. And that goes back to my earlier point, which is find something that you can kind of take your data and look at, as Jennifer says, upside down if necessary. Just find like other angles on it before you make any decisions about where you're going to go. Google Docs, Google Drive, Google Spreadsheets is kind of core to a lot of what people do in the visualization world, and particularly in the data journalism world. Google Spreadsheets have really, really basic charts, but oftentimes they're our starting point for something because we already have the data in a spreadsheet. We just want to get a sense of what it looks like before we export it into something else or try it in something in a third party like a Data Wrapper. Often the very first stab at it could be in a Google spreadsheet. Just make a chart, insert chart, and choose the variables that you want. It's a good starting point. MapShaper, I can't say enough good things about MapShaper if you're working with geographic data. It can be very technical if you want, but it's very base. It will take in almost any form that you can of data that you can imagine. If you've got a shape file, if you know anything about geographic formats, there's shape files, which are very common, map formats, or JSON files, which are increasingly popular for web visualization. But it will take that data and import it and allow you to kind of like spit out new versions of it. Particularly, we use MapShaper a lot for taking in like a shape file and outputting it in an image format or as a JSON file that we can use in something else, or if you get a bit more familiar with it, you can actually filter out bits of the data and only export bits that you need. And raw graphs, we don't use a lot, but it's an interesting project, I think, which is, it makes it relatively easy to take in data and experiment with different shape forms, and then output it in a relatively unpolished, for lack of a better word, but unpolished form that could be used in another application to maybe turn it into something more visual. But it's a good way to experiment with things. Increasingly, I see a lot of people creating stuff in tools like this and then outputting them to like a graphics program or Illustrator or something. So something I can be doing. You could do that. If you are more code savvy, things like R and RStudio is a fantastic tool once you get your head around it, particularly if you're doing fairly complex manipulations with data. It's very useful. Otherwise, observable plot are relatively new kids on the block in terms of the space, but the team has put together a number of interesting ways that you can use code to kind of turn data into observable plots are relatively easy charts if you know a little bit of coding. But those are the kinds of things that we use. Along the bottom, I've got a few other elements here, things like QGIS, which is, we don't use an extensive, but I suspect one of Jennifer's presentation slides there was using QGIS, an open source tool, which is fantastic once you get your head around it to kind of visualize data. It's not the most
and accept the bugs, yeah.
yeah. If you're prepared to put a little bit of time in it, it's super powerful. And if you want to go beyond just kind of like working out, like highlighting things, if you want to start generating your own content and that kind of thing, I think it's really useful. And Leaflet, we use a lot of Leaflet maps, which are kind of code-based, but they make it quite easy to kind of customize what we want. Those are kind of the general tools that I would recommend. I don't know, Jennifer, I think that's more my list than your list, but I don't know if there's anything else.
I think you probably covered everything that I use as well. So yeah, I think we have, I can't think of anything you don't have there. So you want to go on to resources?
Yeah.
So we just added some resources here. The GIJN Resource Center has, a great resource of tools and tips and story examples. I often also look at the Sigma Awards only because that just gets me really inspired about ways people are doing things. IRE.org. IRE is the investigative journalism organization in the US, but we also have a lot of training materials available. This is the address for the presentation, and we do have a few questions. One for you, Alistair, which is the source of your data. Yeah. What about election info?
Okay, so we'll just run through them quickly, I think. From George asking about the data that we use, it's actually an interesting question. We have official stats bodies, the stats body called the Stats South Africa or Statistics South Africa, which are pretty good. But a lot of the data that we get is from, particularly around education, is from the educational authorities. The challenge in that is that the data is often remarkably, should we call it dirty for lack of a better word? It's relatively messy and it needs a lot of work. And this is where we often find that this process of visualization actually comes to the fore. So for example, there's the education department puts out education reports on infrastructure in South Africa. They vary it from kind of quarter to quarter. They put in different versions, but sometimes they put out one and they list the number of pupils and the number of teachers and that. And once you sort of visualize it, you're suddenly starting to look at there are apparently 2 schools in the middle of nowhere that have 1,000 pupils and 2 teachers, and you think, well, there's clearly either something horribly wrong in the reporting, or there's something here that's, you know, worthy of further investigation. And often we've done that in the past, where we look at those and look at the relative sizes of schools, tiny schools, extremely large schools, like what, and those are only really possible when you're looking at 25,000 schools, plus or minus, to actually sort of map those things that are sitting on the outside. So we do a lot of work with that. Elections data, the elections organization, the elections body in South Africa releases data, and they release their identity numbers for the candidates, and it becomes relatively straightforward then to kind of turn those identity numbers into ages. In previous elections, they've actually released the full identity number, which helps us identify genders of the candidates, whereas this particular election only really did the ages, so we could do it. So there's a lot of different sources. A lot of the project data that we do source is semi-official and also improved upon by collection from ourselves. So we do a lot of work around coronavirus, where there is no real official data source. We collect a lot of that information, and that's a significant amount of information. It's almost 2 years now of data, daily data, and we build patterns out of that. So yeah, there's a lot of interesting things in that.
So there's a question about from data journalism educator Anastasia. And data, she says, data viz comes towards the end of the learning process. Do you think it should somehow be moved up earlier, taught together with the analysis? I sometimes find that graphicacy is a skill that has to be built on top of data savviness. Journalists who are just exposed to data journalism find it challenging to get all the design principles to be able to drive conclusions. So I teach data journalism, and I do not teach graphic design or anything, but I do have my students do histograms and scatter plots of their data as part of the exploratory stage of their data, just because I think it pops out at them very quickly if there's any patterns or outliers. So I do think, like, sort of what I call, you know, graphics for my own use helps. But, you know, more advanced stuff, you're right, you might want to save that till later. I don't know, Alistair, what your thoughts are on that.
Yeah, I think it's an important question. It's an important thing that we grapple with a lot. I think what Anastasia says is completely correct. I think a lot of people like not being particularly data savvy, and then trying to get people to look at visualization in its current form, as most people imagine it, is a real challenge. I don't think people understand it necessarily. You do need a level of savviness. But I think what Jennifer says is completely right. I think the challenge for educators particularly, and something that we've been looking at, is how do you introduce just that basic kind of data visual understanding at an earlier stage. And I think it goes back to our earlier point, which is, I think people see these end products, and we look at the New York Times and think that's visualization. It certainly is, and it's the pinnacle of it in many ways. But what we're trying to talk about is, how do you get people to just do the basic stuff that maybe never ever get published? You know, maybe the first draft that they throw away, maybe the handwritten, you know, back of the napkin kind of thing. That's to try and get that into it, I think, is also, I think, one of the challenges, and I'll stop after this, but one of the challenges with teaching data journalism and visual stuff is that, you know, it's like we teach people spreadsheets and then we teach them data visualization. And sometimes just the two put together, like you actually need to see, okay, if I make this change in the spreadsheet to these numbers, what does it look like visually? I can see that relationship with one another. And I think that's quite hard to often get, but it's a very valuable question. Yeah.
Another question from Anastasia, a question on mapping. I do agree that mapping gives us leads into where the clusters are, but then I feel like there should be more geographic analysis, like the % of effective area, comparison of distances. What kind of geographic data analysis do you find to be the most useful? For me, you're completely right. We were kind of focusing on like how to use it to find tips in reporting. But depending on the topic that you're doing and the nature of your data, whether you're working with point data or working with polygons, you often do need to do more sophisticated analysis, normalize the data by some other thing like area or underlying population. So that's a very good point. Alistair, do you have any thoughts on that?
No, but it's again, it's a good question. I mean, we see it with a lot of things. I think one of the challenges with mapping, I think one of the things we get asked the most for is maps of some or other sort. And oftentimes maps don't necessarily, they're quite challenging to always get across the nuances of something. So as you say, I mean, it's one thing just to say where things are clustered, but what are the dimensions to that are quite hard to visualize. But it is a challenge. It's a good question.
Another question about how would you begin doing statistical concepts with sets of data one receives? Honestly, when I most often now use R for statistical analyses for myself, but when I do training, I do I do a lot of it in Excel. My students are able to do a lot of basic statistics, correlations, regressions, visualizations in Excel or in Google Sheets. So I think a lot of it can be done with pretty simple tools. Do you ever link up with tech companies for any real-time data sets? I've read that that's increasingly a thing. Especially among economists. I don't have experience with that. I don't know if you do. You're muted.
Sorry, not particularly. I think a lot of, I mean, there are people out there that do that. A lot of the, I think a lot of the stuff that we're talking about is kind of things that we do investigations over a period of time, and you're collecting data over time. It's not necessarily in this particular instance about like what's happening this minute and next minute. So no, we don't particularly do that either, I think.
I will say though, one thing that we use quite a bit, if you use in Google Sheets, there's a like a little scraper tool called import HTML. And if you use that, it will and the data site that you are grabbing the data from refreshes, it will refresh the data in the Google Sheet, which is super helpful.
Yeah, I think that's a good case point. It made me also think as well that, I mean, I suppose the closest that we come to kind of any kind of real-time data is looking at things like Twitter and stuff, where we collect data over a period of time. So it's not really so much about its immediacy, but it's collecting. I give case in point, and we've collected over a long period of time the Twitter accounts of political parties in this country, for example. More as not just to see what they're saying as of today or yesterday, but rather what are they saying over a period of time. In the same sort of thing around coronavirus, we've collected a lot of that information. Because a lot of the official information is put out via those channels as opposed to actual releases. So that's the closest we probably come to any kind of semi-real-time data.
Okay, I think I got all the previous questions. Let's see if there's any more questions.
Yeah, Anastasia says that there's a Google Sheet, a built-in function. Yeah. I've seen something like that. We haven't used it extensively, but I have seen that. Yeah.
I think so. When I'm doing training for students on, I have a class I call the Data of Divides, which is about using data to cover inequality. We start with spreadsheets and like doing the descriptives and doing the histograms and the scatter plots so that they really understand their data before they move on to the next step. And so I think that could be very helpful.
Okay.
Any other questions?
Doesn't look like it. Okay. Okay, well then I suppose let's not keep people unnecessarily. The presentation is at this link, so which I think Anna did share in the, along with a lot of other, Anna shared a number of resources from GIJN, from the Resource Center that is useful, as well as a link to this presentation. So if there's no more questions, yeah, Anna's just said it again in the chat if you want that. Okay, but otherwise, thank you very much.
Yeah, we'll hang out for a bit in case anybody has additional questions, but thank you all.
Good, glad.
And thanks GIJN for a great week.
Okay. Anastasia has a question about schools. I'm quite happy to answer, otherwise you can just send me either way. Do we follow the topic to get an impact? So can I ask Anastasia, when you say the topic, what are you following?
Is it fine if I unmute myself? Because
yes, sorry, yeah, sorry, yes, it's much easier, yeah.
Sure. We've also done a story about the poor infrastructure of schools in Kyrgyzstan. So we compiled the data set of all the schools because it was very poorly presented by the government. And then we analyzed that most of the schools are either in a dilapidated state or in a need of major repairs. So basically, and they are also in remote areas, and children risk their life every day. So we've done a story. And right now, like, we are trying to organize a discussion with the government representatives. But my question was like, how long do you follow the topic, and did you get any impact?
Yeah, so that's an interesting question, because it's something that's very close to us. So in South Africa, we have a problem. I'll give you an example. In South Africa, we have a particular part of the country which has very, very poor infrastructure at schools. When I say infrastructure, I mean they have what we call pit toilets. They don't have actual toilets. They have a hole in the ground. They don't have water. They don't have basic infrastructure like fences and oftentimes buildings. So what we've done is we've actually connected with an organization that works more on the legal side to kind of track this over a period of time. And we've been doing it for a number of years now, and we're about to start what is essentially so we started in, I think, 2018. And the objective in 2018 was just to see what officially was known about these schools, and then actually we had people on the ground that went to the schools to verify whether the information was true. And we built that into a visualization in that particular case, which went to Parliament. It was used by them in a court case and such like. So it had an element of impact. We then did another one earlier this year, which was a follow-up to that previous one, to see whether there was any progress. So, and then we're actually looking at building a tool now with the same organization to kind of track so that people can start feeding information in. So yes, the thing is that we've looked at this has become a long-term project since 2018, where we try and both have an impact and also keep track of that over a period of time, so that we can say, well, in 2018, we said this was the state of schools. In 2021, this is the state of schools, and basically nothing has changed, unfortunately. And so that has led on to a number of legal cases. It's gone to court. It's been in court a number of times. So yeah, we tend to focus on issues that we can track over a period of time as much as possible.
Yeah, thank you very much. Did I understand right that you actually had funds to collect your own data, or did you partner with the organization that was collecting the data?
So we do a bit of each, but there's an organization in South Africa called Section 27, and they focus on schools. They have people that actually in the different areas that kind of work for them. And they were able to go to individual schools and verify. So they would go and take pictures of the toilets, for example, to say, well, this is the state of the toilets, this is not. So to a large degree, they provided the funds. We collected a lot of the official or the documented data that had been put out. But on the ground stuff, we connected with an organization that had those resources, that could actually have connections with the schools and the school governing bodies and the teachers and the parents and that kind of thing.
Thank you.
Okay.
So I think I answered a couple of the questions in the Resource Center.
Okay.
One was, and if you have any thoughts on how to visualize investigations on air or water pollution.
Not particularly, though. No, there's people much more versed in that. There's some good examples out there.
There's also, I think there were a few sessions as well, and I didn't make it to everything. You know, when you're actually having to work and attend a virtual conference is challenging, but you have access to the conference later. You can go back and watch videos, which I have a whole bunch tagged that I want to go back and watch that I wasn't able to. So there's probably some really good sessions specifically on that.